In this video, we're going to be testing the claim about a mean where sigma is unknown, and we're going to be using the p-value method. This is the formula to find the test statistic, but we're not going to be using this formula. We're going to be using a calculator, but if you want to use a formula, this is what you would use, and what each part means is over here off to the side. So, let x be a random variable that represents red blood cell count in millions of cells per cubic millimeter of whole blood. Assume that x has a distribution that is approximately normal. For the population of healthy female adults, the mean is 4.8. Suppose that a female patient has taken 6 laboratory blood tests over the past several months and that the red blood cell count data sent to the patient's doctor are as follows: 4.9, 4.2, 4.5, 4.1, 4.4, and 4.3. We are going to be using a 0.05 significance level, and we're going to test the claim that the red blood cell count for this patient is lower than 4.8. So let's go off what we know. We have a list of values right here, which is nice because the calculator is going to do the work for us. And we need to set up our hypothesis test. Well, the claim that the red blood cell count for this patient is lower than 4.8. So we're going to have our null hypothesis, where the mean is going to be equal to 4.8. And then we're going to have an alternative where the mean is less than, because it says lower than 4.8. We also have a significance, an alpha value of 0.05, what it says right here at the beginning. Now, what are we going to do? We have a list of values up here, and we're going to have to work with those. Nicest thing we're going to do is just we're going to put them all into a list for our calculator, and it's going to do the work for us. So we're going to bring up our calculator, and we're going to put everything in a list. So we're going to go to Stat, Edit, and put everything into a list, and I've already done so earlier. So here's everything in order, and make sure you type it in correctly. Once you have everything typed in, we're going to just go to second in mode to get out of the list, and then we're going to go back to Stats, and we're going to go to Tests, and we're going to go to t-tests. Now here we have two options, data and stats. This time we don't have any statistics, all we have is the raw data. So we're going to select data for input and go down to our mean right here, and we just look back our hypothesis test where it says 4.8. So we're going to put 4.8 here. Our list is going to be L1 or whatever list you put the numbers in. Frequency stays 1. And then down here, we need to select the alternative, in which case it's less than, because that's what we have selected or written in here. I'm going to do that, and then we're going to press calculate, and then enter. It'll think about it, and then give us our test statistic of -3.464 and a p-value of 0.0089. I'm not going to bother rounding. It'll be good enough. So our test stat is t equals -3.464, and we have a p-value of 0.0089. So since we're using the p-value method, we're going to look at our p-value compared to our alpha value, 0.05. So 0.0089 is less than 0.05. So since it's less than, we say that we will reject the null. Because the p-value is less than the alpha value, we reject the null. Now, we got our answer, but we still have to type everything in. So we have to actually state our claim, because we need to test the claim that the red blood cell count for this patient is lower than 4.8. And since we have rejected the null, we're going to put this in here and type out our answer. Since we've rejected it, we say that there is sufficient evidence to support the claim. Type that in wrong. Forgot. Put in a D, and there's an M there. Support the claim that the red blood cell count for the patient is less than 4.8. And that's all we do for that. So there is our answer, and there is our little sentence stating what we found. We found that there is sufficient evidence, because when you reject, there is sufficient evidence. And it's going to support the claim that the red blood cell count for the patient is less than 4.8. So zoom out so everything can be seen. There we go.